Hello, today we're going to be introducing section 7.4, which is on quadrilaterals. Our essential question for the day is, how can you classify quadrilaterals? First, quadrilaterals are just shapes that have four sides. That prefix of quad means four and lateral means sides. So together, quadrilateral means four sides, or a shape that has four sides. When a shape has four sides, it can then branch off into three categories. Either two of the sides are parallel. These two arrows mean that those top and bottom sides are parallel, making the shape a trapezoid. Or maybe both pairs of sides are parallel. The arrows on top and bottom of this shape match, as do the arrows on the left and the right of the figure. Since both pairs of opposite sides are parallel, we call this a parallelogram. The last option is a shape to be a kite. Notice in the kite that there are matching markings on the adjacent sides, or the sides that are touching. Those two sides are then congruent or equal to one another, as are these two sides over on the right. So the two sides that are touching one another are the same, but the two sides that are next to each other on the opposite sides are different. So if we're looking at the 1 dash and the 2 dash, those two sides are different. And same thing on the bottom. Those two sides are different. So the definition for a trapezoid is a quadrilateral with exactly one pair of parallel sides. Notice there are no arrows on the left and the right of this figure. Those are not parallel. Only the top and the bottom are parallel. I'll pause the video in a moment after I go ahead and show you all three definitions. A parallelogram is a quadrilateral with opposite sides that are parallel and congruent. So we talked about how the opposite sides have the matching markings for parallel lines, but they also have matching markings for congruency, meaning that not only are they parallel, but they also are the same length. So for example, if this top side had a length of 6, then the bottom side would have a length of 6 as well. Those two little lines mean that they have the same measure. And if you look on the left and the right, I see one little line, one little line. So those individual marks mean that the left and the right are also the same as one another. So top and bottom are both parallel and congruent, as are the left and the right. Lastly, for a kite, a quadrilateral with two pairs of congruent adjacent sides and opposite sides that are not congruent. So two pairs of congruent, this means the same, and adjacent means touching. So two sides are the same and they are touching. And that's what we see here. This one marking matches with this one marking. Those are the same as one another and they touch right here at this point. The two sides are touching at that point. But the opposite side, so if I go straight across from one of the sides, I end up at the opposite side, which is here. That is not the same because it has two marks. But that 2 marks is the same as this other side with 2 marks. So those are also adjacent and congruent. But they are different from the left side of the figure, which only has 1 mark. If you need, you can go ahead and pause the video now to continue writing down these definitions. After this, we have a rectangle. A rectangle is a parallelogram. So top and bottom are parallel, left and right are also parallel. But beyond that, a rectangle has 4 90-degree angles. All of the angles in this figure are 90 degrees. So the definition for a rectangle is a parallelogram, so opposite sides are parallel, but more specifically, it has 4 right angles. Now we could also, instead of a rectangle, have a rhombus. A rhombus does branch off of a parallelogram, that's what this arrow means. So that means the opposite sides are parallel and congruent. However, we're going to go one step further and say not only are the opposite sides parallel and congruent, but all 4 sides are congruent to one another. These 4 dashes mean that all 4 sides of this figure are the same as one another. So a rhombus is a parallelogram with 4 congruent sides. Lastly, we have a square. Now notice, a square comes from both a rectangle and a rhombus. So it must be a parallelogram because a rectangle is a parallelogram and a rhombus is a parallelogram. So it must be a parallelogram. The special part about a rectangle is that it has 4 right angles. The special thing about a rhombus is that it has 4 congruent sides. So a square must be all of that put together. A square is a parallelogram with 4 congruent sides and 4 right angles. So in a square, essentially, all the parts are the same. All 4 sides are the same, and all 4 angles are the same. If you need to pause the video now to continue writing these definitions, feel free to do so. We're going to go ahead and classify each of these quadrilaterals now. So in A, I see that it has 4 congruent sides, and I'll use the symbol for congruent. And I also see that it has 4 right angles. Since it has 4 congruent sides and 4 right angles, this figure must be a square. If you need, you can look back to our last page for definitions. Letter B, I see 2 sides are the same, and notice that those 2 sides are touching at this point. They're not across from one another, they're right next to one another. But on the other side of the figure, I see 2 congruent sides that are different. They have 2 tick marks instead of the 1 that the other side has. So half of the figure has 1 tick mark, the other half has 2 tick marks, making this figure a kite. Now go ahead and take a moment to pause the video and try the next 3 on your own. This first one has 4 congruent sides. Since all 4 sides are the same, this must be a rhombus. It could be a square, but we don't know anything about the angles. If all 4 angles are 90 degrees, then it's a square as well. But we only know that the sides are the same, which makes it a rhombus. Here I see that the top and the bottom are parallel, but the left and the right are not. The left and the right have 2 tick marks that match. Since only the top and the bottom are parallel, that does make this a trapezoid. We can further this classification using the tick marks on the left and the right of the figure, but for now we're not going to do that. We're just going to say this basic figure is a trapezoid, and those 2 tick marks on the left and the right, those tell us nothing about the figure at this point. Number 3, I see that the opposite sides are congruent, so the 2 tick marks on the top match with the 2 tick marks on the bottom, so the top and the bottom are the same as one another. And also, the left and the right have a single tick mark that match, which mean the left and the right are also the same. Since the opposite sides are the same, and all 4 angles are 90 degrees, as we can see by the markings in the figure, this shape must be a rectangle. It cannot be a square, because all 4 sides are not the same as one another. We only know that the opposite sides are the same, making it a rectangle. Our last part to this lesson is to talk about the sum of the angles in a quadrilateral. If we had a triangle, and we were talking about the angles within the triangle, we should know by now that the 3 angles within a triangle, x, y, and z, those 3 angles are going to add up to, or have a sum of, 180 degrees. In a triangle, the 3 angles add up to 180 degrees. Now, similarly, in a quadrilateral, if we have 4 angles, they always will add up to the same number. But that number this time is 360 degrees. So for a triangle, it's 180, and for a quadrilateral, it's 360. And you can think of it like this. If I have a shape with 4 sides, I can draw a diagonal down the middle and create 2 triangles. So really, all I'm doing is taking two triangles and adding them together. So if I have 180 for the top triangle and 180 for the bottom triangle, I'm going to end up with that 360 degrees. So if I take all four angles, W, X, Y, Z, and add them up or find their sum, I will see that W plus X plus Y plus Z is equal to 360 degrees. Add the four angles and we get 360 degrees. So in example 2, I need to find the value of X. Well, I know that if I start with X and add all four angles, X plus my next angle is 115, plus my next angle is 70, plus my next angle is 75, I am going to equal a total of 360 degrees. In order to solve, I need to make sure that I simplify the left-hand side first. So I'm going to add up these three numbers. And when I do that, I end up 260. Still equals 360. Now I need to solve for X or isolate X. So I'm going to go ahead and subtract my 260 from both sides. In doing so, I isolate my X, and I find out that X is equal to 100. So the missing angle in this quadrilateral is going to be 100 degrees. In number 4, same thing. I'm going to start with X. I'm going to add all four angles. So I have 100, I have 80, I have 100. Now that I've added all four angles, I know that this is going to equal 360. So X plus, when I add all three of these numbers together, I get 280 is going to equal 360. Now from here I can go ahead and isolate X, and to do that I simply subtract the 280 from the left and the right hand side of my equation. And subtracting, I find that X is equal to 80. Go ahead and take a moment to pause the video and try the next and last four on your own. As soon as you're done, go ahead and use what I've done to go ahead and check your answers. And after you're done checking your answers, that's all I have for you today. Thanks so much for watching.